Hello everyone, I'm Emad Tadi from Pattern Recognition Lab at Firdaus University of Mashhad and this tutorial for electrical and electronic circuit lesson. Today I want to speak about R to R digital to analog converter. It's an essential electronic component used to convert digital signals into analog voltage by utilizing a simple resistor network of just two resistor values R and 2R. This architecture not only streamlines the design but also increases reliability in signal conversion. You can see my project in this link. What is R2R digital to analog converter? R2R DAC is a data converter that used to precision resistor to convert a digital binary number into an analog output signal or potential to the value of the digital number. You can see R2R resistive ladder here. As its name implies, the ladder description comes from the ladder-like configuration of the resistor used within the network. A R2R resistive ladder network provides a simple means of converting digital voltage signals into an equivalent and analog output. Input voltages are applied to the ladder network at various points along its length, and the more input points, the better the resolution of the R2R ladder. The output signals as a result of all these input voltage points is taken from the end of the ladder, which is used to drive the inverting input of an operational amplifier. Then a R2R resistive ladder network is nothing more than long strings of parallel and series connected resistors acting as interconnected voltage dividers along its length, and whose output voltage depends on the interaction of the input voltage with each other. Consider the basic 4-bit R2R network here. Include parallel and series resistors and output voltage, and this output voltage connected to amplifier. This 4-bit resistive ladder circuit may look complicated, but it's all about connecting resistors together in parallel and series combination and working back to the input source using simple circuit laws to find the potential value of the output. Let's consider the binary inputs are grounded at 0 volts, that is, VA and VB and VSC and VD equals 0 volts. The binary code corresponding to these four inputs will therefore be 0, 0, 0, and 0. Such this. And then we have R2R DAC with input VAA, and we connect 5 volts power supply to input VAA. And we have inputs VA is high and logic level 1 and all the other inputs grounded at logic level 0. As the R2R ladder network is a linear circuit, we can find Thevenin's equivalent resistance using the same parallel and series resistance calculation as above to calculate the expected output voltage. The output voltage Vout is therefore calculated at 312.5 millivolts, like here. And as we have a 4-bit R2R resistive ladder network, this 312.5 millivoltage change is 1/16th of value of the 5 volt input voltage, so is classed as the least significant bit. Being the least significant bit, input VA will therefore determine the resolution of our simple 4-bit digital to analog converter, as the smallest voltage change in the analog output corresponding to a signal step change of the digital input. Thus, for our 4-bit AC, this will be 312.5 millivolts for a 5-volt input. And then when we connect 5 volts power supply to VB, what we have. With input VB high and logic level 1 and all the other inputs grounded at logic level 0, the output voltage Vout is calculated at 625 millivolts, and which is 1/8 the value of the 5-volt input voltage. We can also see that it's double the output voltage when only input bit VA was applied, and we would expect this is as it's the second bit input, so as double the weighting of the first bit. Here we have a simple digital to analog converter with a parallel series resistor and operational amplifier here. And in the left of this video, we have one example for when we have the input hexadecimal this code. We have this resolution and this output. In this article, we learned about the digital to analog converter and its structure and example. Digital to analog converters plays a crucial role in the bridging the gap between digital signal processing and the analog world. At their core, they translate the binary data compressing zeros and ones into continuous electrical signals that devices can interpret. This process is essential in various applications from audio playback to video transmission and telecommunication. Thank you for listening. Wish you all the best.